Claudia Bertini. I'm working at IHE Delft, and within the project I am focused in the work package 7, so with the case studies, and mainly in the case study of the Netherlands. And but also I'm focused in the forecasting part of extreme events, mainly droughts at the moment.
And my name is Dorien Lugt. I'm working for HKV as a flood risk and water management consultant, and I'm also in work package 7 on the local case studies for the Netherlands. I'm doing 2 case studies.
Our hotspot is the one of the Rhine Delta, and it actually has specifically 3 different areas of study. One is Rhineland, one is Rhine-Maas, and the other one is the main water system in the Netherlands. And let's say that in general, we can consider the entire country as a delta area, and it is dependent largely on surface water, and which is now, let's say, threatened a bit by droughts, both for surface water availability and quality. But also the country is prone to the risk of flood, both coastal and river floods. So the problem with climate change is that the frequency of these events may change in the future, and they could become more frequent. So it would be useful to know if there is any change in this frequency to communicate it to stakeholders so that they can start planning mitigation actions.
Main water system, in which we look at the potential implications of extratropical cyclones. And in the other work packages, many researchers are focusing on climate projections for whether these extratropical cyclones will increase in occurrence. And in this case study, we will look at the potential impacts in terms of storm surges, for example, on flood risk in the main water system.
In the other 2 case studies, they are the areas of Rhineland and Rhine-Maas, and these areas are affected by drought events, mostly in the summer, and these drought events are threatening the availability of surface water that is used for agriculture, for tourism, and these kind of things. So within the CLINT projects, we want to address this problem, and we want to improve subsequent forecasts of droughts. For Rhineland and Rhine-Maas, the main stakeholders are the water management authorities, which are called water boards in the Netherlands. And we also have some secondary stakeholders, and these are mainly the representative of the economic activities, so agriculture and water tourism. And the main outcome that we plan to offer to the main stakeholder is to have earlier and also more reliable drought warning, so that the stakeholders can actually plan way more in advance all the mitigations, the impact mitigations actions, such as, for example, planning dike inspections and change the inlet locks, but also, which is probably the most important, to organize like an alternative route for water supply, because they need to fight salinity infiltration in surface water. And also another outcome would be that once the main stakeholders know in advance about these events, they can also communicate in advance to the secondary stakeholders, so to the water tourism and agriculture, so that they themselves can plan mitigation with the time that they need.
For Rijkswaterstaat, when we approached them about this project, we told them about the different aspects that will be studied, and they were very much interested in the extratropical cyclones, because currently this has not much attention in the Netherlands, and it is a big question whether this in future climate will be a relevant factor for flood risk. And with the recent developments in climate models, there is new insights becoming available, and for Rijkswaterstaat it's useful to know all these newest insights. So as a CLINT project, we can provide in the translation from the fundamental science towards the policymakers.